it was the same as the last one but there is a little difference. This is another example. Write a program using interrupt to the following. Receive the data and send it to P0. Have P1 port read and transmitted seriously. And a copy given to P2. Make a time zero or generate a square wave of 5 kHz frequency on P01. This example, I don't simulate here. You can do it by yourself. In the serial communication, the TCON register hold 4 of the interrupt flags. The SCON register has the RI and the TI flag. The interrupt flag. TCON hold 4 of the interrupt flag. SCON has the RI and the TI flag. For the 8052, there is a time zero. We don't introduce it. When the 8051 is powered up, the priorities are assigned according to the following. Interrupt priority. In reality, the priority scheme is nothing but an internal polling sequence in which the 8051 polls the interrupt in the sequence list and respond accordingly. The interrupt priority upon reset is high to no priority. The highest INT0. Second is time zero. And third is the interrupt 1. Fourth times 1. Serial communication is the lowest priority. Discuss that what happened if interrupt times INT0, TF0, and INT1 are activated at the same time. Assume priority level was set by the power-up reset and the external hardware interrupt and edge triggered. This is question. How solution? If these 3 interrupts are activated at the same time, they are latched and captured internally. Then the 8051 check all 5 interrupts according to the sequence listed in the table here. In the table just list the interrupts from high to low. If any is activated it serves in sequence therefore when the above three interrupts are activated IE 0 external interrupt 0 is served first then time 0 then time 0 and finally external interrupt 1 finally time interrupt 1 this is first, this is second, this is third, this is third. We can alter the sequence of interrupt priority by assigning a higher priority to any one of the interrupts by program a register called IP interrupt priority to give a high priority to any of the interrupts. We make the corresponding bits in the IP register high, which means if the IP interrupt priority, the interrupt has the higher priority, higher priority. When two or more interrupt bits in the IP register are set to high, while these interruptions have a higher priority than others, they are served according to the sequence. If any of these interrupt is set to high in the same level, the interrupt is served according to this table. For example, if you give this interrupt to high, if we give this interrupt to high, this interrupt to high, this is 0, 0, 0. For the high level interrupt, the interrupt is checked by sequence according to default. So the interrupt 1 is served first, then the timer interrupt 1. After that, the no-never interrupt is served as default. So this is first for the interrupt 0, time 0. Last is serial communication. This is the interrupt priority register. We can just know the every bit is for one interrupt. The 0 IP point 0 is extra interrupt 0, and 1 is time 0. 2 extra interrupt 1, 3 times 1, 4 is a serial port. If we use 8051, the 5 is received, is reserved, and the 6 3 is reserved. If we use 8052, the 5 is for time 2. priority bit is equal to 1, assign the high priority, priority bit is to 0, assign low priority, no priority. So in the same level, the interrupt is served as a default, Here is an example. Program the IP register to assign the highest priority to interrupt 1. Then discuss what happened if INT0, INT1, and the TF are activated at the same time. Move I interrupt the priority for this register, for this word, set the IP2 to 1, assign INT1 higher priority, the interrupt instruction SETB IP point 2 also do the same things. This instruction gives a higher priority for external interrupt 1. The instruction in step A assign the higher priority to interrupt 1. Then the others. Therefore, when INT0, INT1, and the TF interrupts are activated at the same time, the 8051 serves the INT1 first, because the actual interrupt 1 are assigned higher priority, Then it serves INT0 and then TF0. This is due to the fact that INT1 has a higher priority than the other two. Because of the instruction in step A, the instruction in step A makes both the INT0 and the TF0 bits in the IP register 0. As a result, the sequence in table so we just ignored. We use this example to tell you if we give the interrupt higher priority, the interrupt will be checked firstly. So the 8051 check the interrupt for the higher priority, then lower priority. In higher priority, if you have more than one, the interrupt is checked by default sequence. Okay, let's have a break. Everyone?
Okay, Lashi, thank you.
Let's have a break.
All right.
Yes.
Although all the interrupts are matched and kept internally, no priority interrupt can get the immediately attention of the CPU until the 8051 has finished serving as a high priority interrupt. triggering interrupt by software, triggering interrupt by software to test the ISR by ways of simulation. Simulation can be done with simple instruction to set the interrupts high and thereby cause the 8051 to jump to the interrupt wait table. Example, if IE bit for time 1 is set, and an interruption such as SETB TF1 will interrupt the 8051 in whatever it is doing and will force it to jump to the interrupt wait table. We do not need to wait for time 1 to go roll over and to have an interrupt, which means we can use the instruction to trigger interrupt. So for the testing, the content, left content is for programming in C language. I don't introduce this part. You can read it by yourself. You can read it yourself. For this chapter, we know something about the interrupt and how to set the priority and how to write the interrupt service routing. Interrupt service routing. So for this chapter, you can do some assignment for the two example I didn't simulate in the class. This one, you can do the simulation. As your assignment. Next, I give you the new class. LCD and the keyboard interfacing. We have finished the introducing 8051 internal function. Next, we will introduce the interfacing for the 8051. LCD is for displaying. As we know, microcontroller is just like a microcomputer, but the microcontroller without